Welcome to the deep dive. Today we're really getting into something fundamental for RC car fans, especially if you run Tamiya stuff.
Yeah.
Pinion gears.
Mm-hmm.
Aluminum or steel. Which one's right?
Exactly. We've got a bunch of technical info here looking right at these materials, but
Yeah.
specifically, in the Tamiya context. They're tuned motors, it's classic
Yes.
buggies. Grasshopper, Hornet, Lunchbox,
Falcon,
Chief.
Grasshopper 2, Rising Fighter. Yeah, all those.
Right, all of them.
And our mission for this deep dive is pretty straightforward. Cut through the noise and give you solid advice on picking the right pinion.
Yep. We want you to get the knowledge quickly, properly, understand the performance, the reliability, the lifespan.
Without feeling like you need an engineering degree.
Exactly. Because, this little gear, it seems small, right?
Tiny.
But it's the first place the motor's power goes. It takes all that initial force, the high speeds, and it wears out faster than you might think. So the
Yeah.
material, it's a huge deal for the whole drivetrain.
Okay. And something interesting in the sources, this idea of a sacrificial part, like the pinion material deciding what wears out first, maybe saving the spur gear.
That's the idea, yeah. It's the core dilemma. Do you want a softer pinion that wears itself out, maybe protecting the spur, or a tough one that lasts but maybe puts more stress elsewhere?
It's a trade-off.
A classic one. So let's break down the materials, starting with aluminum.
Makes sense. Aluminum pinions, they're like everywhere. Stock and loads of Tamiya kits, right? Especially older ones or the entry-level cars. I think the sources mentioned AV series.
That's right. The AV ones are often aluminum and, common as stock. But it's not just aluminum. There are differences.
Okay.
You've got your basic kind of soft aluminum, wears pretty fast. Then there's a 775 alloy. That's a step up in wear resistance.
Better, but still aluminum.
So aluminum. And then you have hard-coated aluminum. It's got a surface treatment, makes it harder.
So that's the best aluminum option.
It's tougher, yes, but here's the thing. That hard coat, it's thin. Once it wears through, and it will wear through where the teeth mesh, you're back down to the softer aluminum underneath.
Yeah.
And that'll wear quickly. It's not the same as the bulk hardness you get from steel.
Okay, so advantages of aluminum then. Why use it at all?
Well, lightness is often mentioned. It is lighter than steel.
But does it matter much?
Honestly,
Right.
For most bashing around, probably not a noticeable difference. The pinion's tiny. It's cheaper up front, usually.
Yeah.
Widely available. And like we said, there's that potential sacrificial element with the really soft stuff.
But you sound hesitant about that sacrificial idea.
Well, yeah. Because with more power, and we'll get into motors soon, that softness is a big problem.
Right.
Aluminum, especially soft aluminum, just shreds quickly with tuned motors. It can bend, deform, the teeth lose their shape.
Leading to bad mesh.
Exactly.
Oh.
Bad mesh, more wear.
Mm.
And the other big issue is the dust. As it wears, it creates this fine aluminum powder.
Which gets everywhere.
Yep. Into bearings, grinds away at your spur gear.
Yeah.
It's abrasive stuff. So the sacrificial idea, it sounds okay, but the normal wear with a tuned motor can damage the spur gear anyway. It's often a false economy.
Okay, that makes sense. So steel then, the alternative.
Steel.
Yeah.
Yeah, this is generally what you want for durability, especially when you add power.
Are there different types of steel too?
There are. You've got standard steel, already way harder than aluminum, and then hardened steel. That's the top choice for really high power brushed motors or, any brushless system.
Benefits seem obvious.
Yeah, superior hardness, much better durability. It just resists wear so much better. Handles high torque, high RPM without breaking a sweat. Inherently stronger.
Downsides. Has to be something.
Well, it's heavier, but again, negligible difference in most cases.
Okay.
Costs a bit more to buy, but it lasts so much longer that cost often pays for itself.
Right.
Maybe a little more noise, especially steel on steel or if the mesh isn't spot on.
And can it damage plastic spur gears? People worry about that.
It can, yes, if it's a poor quality pinion with rough teeth or if the mesh is way off. But a good quality steel pinion, meshed correctly, it's actually very kind to plastic spur gears. Helps them last longer because the pinion teeth keep their shape.
Gotcha. The sources had a comparison table, right? Showing hardness, wear, cost.
Yeah, super useful. Visually sums it up. Aluminum's maybe got a slight edge on initial cost and weight, but steel, especially hardened steel, just dominates when it comes to strength, wear resistance, handling power, longevity.
Okay, let's drill down into those specific Tamiya models our listener mentioned. Grasshopper, Hornet, Falcon, Lunchbox, Grasshopper 2, Rising Fighter. What are they typically running stock?
Stock. A lot of those came with soft aluminum pinions. You know, the Rising Fighter often has a 17-tooth aluminum. Grasshopper with a 540 motor, usually aluminum.
Lunchbox.
Lunchbox uses that CW01 chassis, often a 10-tooth pinion. Might be brass sometimes, but still generally a softer metal than proper hardened steel.
And why was that? Just cost?
Likely cost, yeah, and they were usually paired with pretty mild stock motors back then. The silver cam 540s or even 380s.
And the rest of the drivetrain. Spur gears, gearbox internals in those models.
Mostly durable plastics, nylon, things like that. For the spur, for the internal diff gears. And they're often in sealed or semi-sealed gearboxes.
Like the Lunchbox CW01.
Yep, that's a good example. Sealed gearbox, plastic diff gears. The Rising Fighter uses a gearbox based on the DT01, also plastic internals.
So plastic spur gears are common in these.
Very common, which makes the pinion choice really important if you upgrade the motor. Because a good steel pinion is generally better for the plastic spur's lifespan, especially if you're running more power. That rapidly wearing aluminum pinion, it can actually chew up a plastic spur pretty badly once the teeth deform, or it generates all that dust.
Right. And gear pitch. We need to mention that. Matching sizes.
Oh, absolutely critical. Can't mix them. For these models, especially with 540 motors, the standard pitch is 0.8 module, sometimes called 32P or 32 pitch. Same thing in this context. It's the size of the teeth. Your pinion must match your spur.
And tooth counts for these.
Grasshopper Hornet usually run an 18-tooth with a 540. Lunchbox is that little 10-tooth. Rising Fighter comes with a 17T, often has an option for 19T. Falcon, being similar era, likely 0.8 module too.
Important note, stick to 0.8 module for these.
Yeah, for these buggies and trucks with 540s, it's almost always 0.8 module. Tamiya uses 0.6 module, the AV pitch, elsewhere, but not typically here in the standard configuration.
Okay. Materials, stock setups. Now, the big one, power. Sounds like the motor is really the deciding factor here.
It absolutely is the biggest factor. And Tamiya gives you a pathway with their tuned, brushed motors.
Right, they have a whole series. Torque tune, sport tune, GT tune. How do they stack up? What does it mean for the pinion?
Okay, so the key metric is turns. Lower turns generally means more power, more RPM for brushed motors.
Right.
So the Tamiya 540 tuned line, the torque tuned gives a bit more grunt than stock. The dirt tuned, similar, maybe more torque focused. The sport tuned aims for more speed, higher RPM.
And the GT tuned?
That's kind of the top of that specific brush range. Good combo of torque and RPM.
Yeah.
So power-wise, it generally goes stock 540, then torque tuned. Then sport tuned and dirt tuned are roughly similar. And then GT tuned is the hottest of that group.
And more motor power means?
More stress on that pinion gear. Simple as that.
And then we go beyond those Tamiya tuned motors. What's next?
You get into what people call hot brushed motors, usually under 20 turns. Significantly more power, more RPM than even the GT tuned. Puts a lot more strain on things.
And then brushless.
Brushless, yeah, that's a whole different ballgame. Huge jump in power, torque, efficiency. Rated in kV RPM per volt, or sometimes still in turns, but lower turns means way more power.
Even a mild brushless is a big step up.
Oh, yeah. Even a modest brushless system can stress a pinion way more than a hot brush motor. Remember that story from the sources? Aluminum pinion lasted years with a silver can.
Propped a 5,700 kiloV brushless in, and boom, shredded the pinion in one run.
Wow. Okay, so how does more power wreck pinions? What's actually happening?
It's a few things. Higher torque, that puts more shear stress on the teeth. Soft aluminum teeth could just bend or strip right off.
Okay.
Higher RPM. That means more contacts per second between the gear teeth, so abrasive wear happens much faster. Plus more friction, more heat, which weakens aluminum.
Makes sense.
And then there's just the driving. More power means faster acceleration, harder braking, bigger jumps maybe, those shock loads to the drivetrain. Aluminum just can't handle those sudden impacts as well as steel. It can deform or fail completely.
Okay, so knowing all that, when can you get away with aluminum? Are there any situations left where it's okay?
Very limited situations,
Yeah.
and always with warnings. Stock 540 silver can, maybe, in a light 2WD buggy, like a Grasshopper.
If you're gentle.
Yeah, and you maintain it well. Check it often. It might last a reasonable time.
What about the milder tuned motors, like the torque tuned? Maybe a hard-coated aluminum pinion with the torque tune, possibly a sport tuned if it's a really light car, but you have to be super diligent. Check it constantly.
So it's a compromise.
Totally a compromise. You're trading longevity for maybe a slightly lower initial cost or easier availability. The sweet spot for aluminum is just really narrow.
And that sacrificial idea, using soft aluminum on purpose.
Again, sounds okay in theory for like a massive bind-up. But with tuned motors, the normal wear happens so fast, it'll likely cause poor mesh and damage your spur with dust long before it ever saves anything in a crash. It's just not reliable protection, and it causes other problems.
So it sounds like the risks of aluminum pile up pretty fast once you upgrade the motor at all.
They really do. Accelerated wear, constant need for inspection and replacement, that nasty aluminum dust contaminating everything, teeth deforming under load. And the quality of aluminum pinions varies a lot too. Cheap ones can be shockingly soft.
Paints a clear picture.
Oh.
Okay, steel. When does it go from good idea to you absolutely need this?
There's definitely a tipping point. Within Tamiya's brushed motors, once you hit the GT tuned, steel is highly recommended. That extra torque is the signal.
And beyond that.
For anything more powerful. So hot brushed motors under 20 turns or any brushless system. Steel is mandatory, non-negotiable. Aluminum just won't survive.
Other factors, like the car itself.
Yeah, heavier vehicles, running on high traction surfaces, aggressive driving styles, all that puts more stress on the pinion. So even with a moderate motor like a sport tuned, steel becomes advisable in those conditions.
Or if you just want it to last.
Exactly. If maximum durability and minimum hassle is your goal, steel's the better choice even with a mild motor in a light car.
And the benefits of steel in those tougher scenarios.
Much longer life, obviously. Reliability. Crucially, it holds its tooth profile under load. That's key for good mesh and keeping your spur gear healthy, and just less maintenance overall.
Okay, pairing it up. Steel pinion. You said plastic spur gear is common in these Tamiyas. Is that okay?
It is. Steel pinion with a plastic spur is a very standard, very effective setup for these kinds of vehicles.
Even recommended.
Generally, yes. The plastic spur can act like a fuse in a really bad jam-up. Cheaper to replace a spur than wreck internal gears.
But required.
Requires a good quality steel pinion smooth teeth, properly formed and correct gear mesh. That's vital. Forget the myth that mixing materials is bad. This combo works great. For your Tamiya buggies, the main win is the pinion lasts ages and the plastic spur wears predictably.
What about steel on steel?
Really only for extreme power levels, not necessary for these applications, needs very precise setup.
And steel pinion, aluminum spur.
Bad idea, don't do it. The steel will just eat the aluminum spur for breakfast.
Okay, let's sum up the risks and rewards then. Aluminum.
Rewards. Cheaper initially, slightly lighter, but maybe not noticeably, maybe sacrificial, but unreliable with power. Tamiya sells branded ones. Risks. Wears fast, bends, makes abrasive dust, can kill your spur gear when it fails, needs lots of checking.
Steel.
Rewards. Way more durable, lasts much longer, reliable under power, less maintenance, better for drivetrain health with a plastic spur. Risks. Costs more upfront, tiny bit heavier, maybe noisier, can wear a plastic spur if it's poor quality or meshed wrong.
Very clear. Very specific recommendations for our listeners' Tamiya fleet. Let's say they're using Tamiya tuned motors.
Okay. Torque tuned, dirt tuned, sport tuned in, those lightweight 2WDs, Grasshopper, Hornet, Falcon, Rising Fighter, GH2.
Yeah.
You could use hard-coated aluminum, but expect wear. Check it often, like every 5-10 runs. It's a compromise.
But the better choice.
Steel pinion. Strongly recommended. Better life, less worry. That should be the default upgrade.
And the GT tuned motor.
Steel pinion. Hardened steel, preferably. Highly recommended, almost mandatory because of the torque.
Okay. Now, more powerfully tuned motor.
Hot brushed, any brushless.
Steel pinion.
Yeah.
Hardened steel.
Yeah.
Mandatory. Full stop. Aluminum is completely out of the question.
And for those specific chassis, Grasshopper, Hornet, Lunchbox, etc., maybe even with the stock motor. Stock silver can. The stock aluminum pinion is adequate, but it will wear. Upgrading to a 0.8 module steel pinion, same tooth count, is a good durability boost even then.
And if you put any tuned motor or better in them?
Steel pinion. 0.8 module, correct tooth count for your gearing. Definitely. Remember those common counts? 10T for Lunchbox, 17, 18, 19T, often for the others.
And bore size for the motor shaft.
Ah, good point. For 540 motors, it's typically 3.175 millimeter, 18th inch. Make sure the pinion bore matches.
And steel works okay with the plastic spurs in those gearboxes.
This works great if the mesh is right. And actually, you know, those older chassis can flex a bit,
Right.
which can make holding perfect mesh tricky. A steel pinion, because it keeps its tooth shape, is actually a bit more forgiving in that situation than soft aluminum that might deform.
Good tip. Okay, we've covered materials, when to use them. What about just general best practices? Keeping the drivetrain happy regardless of pinion type.
Gear mesh, number 1. Absolutely critical.
Too tight.
Bad. Friction, heat, whining noise, fast wear, strains the motor, and ESC. Also bad. Gear slip. Teeth get chipped or stripped horrible grinding noises.
How do you set it right? The paper trick.
The paper method is a good starting point. Slip a strip of paper between the pinion and spur, push them together, tighten the motor. You want the paper to come out slightly crinkled, maybe with faint teeth marks.
Just a starting point, though.
Yeah, experienced folks often fine-tune by feel and sound. You want the tiniest bit of backlash, free play between the teeth, but absolutely no binding as you rotate the spur. Check it at a few points around the spur gear, as they aren't always perfectly round.
Okay. Lubrication.
For sealed gearboxes, like in these Tamiyas, a light coat of plastic-safe grease on the internal gears is good. Tamiya Cera Grease HG is often recommended.
What about the pinion and spur itself?
If it's enclosed in a gearbox cover, a tiny bit of light grease is okay if it's exposed to dirt. Probably best to avoid grease, it just attracts grit. Maybe a dry lube, like a PTFE spray, if you want something.
Don't overdo it.
Definitely not. Too much lube just creates drag and makes a mess.
In general maintenance.
Regular checks. Look at the gear teeth for wear, especially if you're running aluminum. Replace worn parts promptly.
Motor mount.
Make sure it's tight. A loose motor means the mesh changes as you run, leading to stripped gears. Happens all the time.
Cleaning.
Yeah, periodically clean out the old grease and any dirt from the gearbox, then re-lube lightly.
Bearings.
Check them, spin them, should be smooth. If they feel gritty or seized, replace them. And honestly, if your car still has plastic bushings, upgrading to ball bearings is one of the best things you can do. Reduces friction, improves efficiency, and makes the whole drivetrain more stable. Helps maintain that gear mesh under power, too.
Great advice. Okay, let's wrap this deep dive up. What's the core message for our listener?
I think the main thing is that little pinion gear. Choosing the right material is really, really important for your RC car's performance and how long it lasts.
And the summary is?
Aluminum. Okay,
Yeah.
for very basic setups, if you watch it like a hawk, but steel is the clear winner for pretty much any upgraded power, or just for overall reliability and less hassle.
And pay attention to the specific Tamiya recommendations based on motors.
Absolutely. And remember, no matter what pinion you use, getting the gear mesh right and doing regular maintenance, that's always crucial.
Excellent. And maybe a final thought for you to chew on. Isn't it kind of cool how this tiny component, the pinion gear, shows just how much engineering and material science goes into even these hobby cars?
It really does.
Understanding these details, like aluminum versus steel, can seriously boost your fun and make your cars last longer. Maybe now's a good time to look up some specific .8 module steel pinions for your Tamiya fleet and those motor upgrades you're planning. Thanks for diving deep with us.